Alright, let's look at the homework 15.8, problem number 9. Alright, so we want to use cylindrical coordinates to find the volume of the solid enclosed by the cone, z equals square root of x squared plus y squared, and the sphere, x squared plus y squared plus z squared is equal to 32. Alright, so let's do that. Alright, so we need to draw a picture first. So you have, here's the x-axis, and here is the z-axis, actually y-axis I meant, and here is the z-axis. Alright, then we have a sphere, and radius is square root of 32, and so I'm going to just try to sketch that. So you just have a sphere. So I'm gonna, whoops, that's not the color I wanted. So let's try something like that. So I'm gonna just draw a sphere. It might look something like that. Alright, then we have, let's say, a cone. So the cone probably should look something like this. And it's going to intersect the sphere. Then you have a solid which looks like that. So if we shade it, so we have a solid which looks like this. Right, and this is going to be a sphere, so it's going to look kind of like that. Right. Right, so we have that. So that is the solid. Right, so let's find the volume. So we have a volume. Alright, so I'm going to use the cylindrical coordinates. So the volume element is r. I'm going to actually do dz first with respect to z, and then dr, d theta. Right, so we have to find the bound for z. So let's say I'm going to fix r and theta. So this is theta. So I'm going to take that. And you can see that if you fix r and theta, z is going to start from the point on the cone all the way to the point where the sphere is. Right? So we know that here the equation of the cone here, we can rewrite it as z is equal to square root of, right, x squared plus y squared is r squared. So this is going to be just r. So here we know that z is equal to r. So it's gonna start from r, right? Then it's gonna end at on the sphere. So I'm gonna have to solve for z here. Right, so z squared is equal to 32 minus x squared minus y squared, right, which is same thing as 32 minus r squared. Then we can take the square root of both sides. So we have z is equal to, and you would have to put a plus or minus, but I will just look at the positive one because we're looking at the top side. So it's 32 minus r squared, right? So you have a square root of 32 minus r squared, right? So that will take care of that, right? The next step would be r is going to start from, say, 0. So here, r is equal to 0, right? Then you can go all the way to the edge here, there where the intersection of the sphere and the cone. So in order to find an intersection of the sphere and the cone, all we have to do is we can just plug this guy in here, right? So we end up getting x squared plus y squared plus, you have another x squared plus y squared. So can I just write the 2 here and the 2 there? Right? Then this is equal to 32. Right? But everyone's even, so I'm going to divide through by 2 to get x squared plus y squared is equal to 16. Right? So the radius is going to be 4, right? Because 4 squared is 16. Right? So the radius is going to be, right, start from 0, right? Then you're going to end up at 4. So it's going to be up to 4. Because the radius from here to there is going to be 4. Alright, then after that, since we have to go all the way through, so we have to, you start from here. So the theta is going to be 0 there. So theta equal to 0. Then you would have to go all the way around once to cover the entire solid. So it's gonna, theta is going to go from 0 to 2 pi. Alright. So we got that. Then we just have to evaluate this. Right? So let's do that. Right? So r has nothing to do with z. So you're going to have, let's see, I'm going to leave those two integral alone. Right? Then antiderivative r with respect to z would be rz. And you would go from r to square root of 32 minus r squared. Right, then you still have dr and d theta. Right, then if you evaluate that, you're going to get this from 0 to 2 pi, integral from 0 to 4. Right, plug in, let's see, square root of 32 minus r squared. So you have r. And then I'm going to have, let's see, 32 minus r squared. And I'm going to write it as 1/2 power there, right? Then minus, and plugging r. So you have r squared, right? So then we just have to do antiderivative with respect to r and with respect to theta. All right, so we got that. All right, so I'm going to do a little bit of tweaking here. Let's see, if we want to, let's say the derivative of 32 minus r squared would be negative 2r. We have already r here, so I'm going to actually put negative 2 here, and then divide by negative 2, right? So that I can find the antiderivative fairly easily. So you have a 1 over negative 2. Then I leave this part alone, so 2 pi. Actually, this is separable, so I'm just going to put it right here. Right? Then here, and I'm going to find the antiderivative of right, negative 2r, which is exactly the derivative of 32 minus r squared. So antiderivative of that would be, right, 32 minus r squared. Right, add 1 to the power, so 3 over 2. And divide by 3 over 2 is equivalent to multiply by 2 over 3. Right, so we have that. You can use substitution, but you're going to end up with the same answer here. Alright, then antiderivative, oh actually, I messed it up, sorry, so I placed this thing, this number in a wrong place, because this only comes from, so I have to put it, right, let's see, right here, 1 over negative 2, right, so right there. Alright, so I'm going to have to put, since this only applies to this term, so I'm going to have to put 1 over negative 2 right there, right? Then antiderivative of r squared would be r cubed over 3, right? Then we are going from 0 to 4, right? So we have to clean up a little bit here, right? So we have, let's see, 2 here and the 2 there cancel out, but the negative sign is still there. All right. So if you do that, you're gonna get. Oh, actually, I don't need that. I already took care of that. All right. So this part is going to be simply plug in 0 and 2 pi here. All right. This guy. All right. So if you plug in 4, you're gonna get. So this is right, negative, right, 1/3 here. And if you plug in 4, so it's going to be a 32 minus 16. So it's going to be a 16, raise it to the 3/2 power, minus, right, then it's going to be 4 cubed, right, over 3, right? And then we plug it in, so it's going to be minus, but we already have a negative sign, so it's a plus 1/3. Then you have 32, raise it to the 3/2 power, right? Then I plug in 0, it's 0, right? So we have that. All right, so we have to clean this up a little bit. All right, so we're gonna have. All right, so this is going to be, let's see, 16, then 1/2 power would be square root, so that's going to be 4, and 4 cubed is 64, so you have, this is going to be 4 cubed with the negative sign, so you're going to have, actually, we have negative 4 cubed over 3 minus 4 cubed over 3, so you're going to have. All right, so I'm gonna just put let's see, I'm gonna put the 2 pi here, right? So it looks like 1/3 is in common, so I'm gonna just pull out the 1/3, right? Then you're gonna have let's see, negative. Let's see, what I say, 4 cubed, so it's a 64. So you have another 64, so it's gonna be minus 128. Right, and then here plus, all right, what's this guy? So 32 is let's see, it's a 2 times 16, right? So 16 is 4 times 4, so you have let's see, so take the square root of 32 would be 4 square root of 2, right? Then you have to cube that guy. So this is going to be 64, and then you have a times 2 square root of 2, which is 128 square root of 2, right? So this is going to be 128 square root of 2, right? Alright, so it looks like a 128 is in common too, so you're going to have, let's see, times 2. So it's going to be a 256 pi over 3. Then I'm going to put the square root of 2 first, minus 1. So I pulled out the 128 from both. Alright, so let's type it in. Alright, so we got 256 and pi, and divided by 3 times, so we need to put the parentheses, and then square root of 2 minus 1. Alright, so let's submit for testing. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.